Good morning. Good morning, everybody. Namaskar. This is Engineer Suraj Singh speaking from Bharat, India on this day, February 24, 2022, Thursday, 3:40 a.m. मैं सूरज सिंह सिविल इंजीनियर भारत इंडिया से बोल रहा हूँ। आज दिनांक फरवरी 24, 2022, वीरवार बृहस्पतिवार सुबह के 3:41। आप सबका धन्यवाद कि आप इतने दिन से मेरी बात सुन रहे हैं। टॉक regarding quality and regarding coordination continues with blessings of God and blessings of all those audience. Title being same as usual with change of number of talk. That's it. Quality projects works, coordination world, communication, network and concrete. Now, quality, project works, coordination, communication, and network. This is one work based on which progress of project depends. It impacts on every project. And we say civil field engineering, which means engineering for all. You can say engineering for all. Field engineering and civil means engineering for people or public, not for particular one. It's particular one but for everyone. Particular one for everyone. And what is required is reliable engineers. That is operator. Engineer here is controller. Engineer here is director. Engineer here is, you can say, without whom nothing can move, no wheel can roll if engineer is not reliable. That's why I say engineers who must be reliable. They are called engineers who can take responsibility, who can be accountable, technically, otherwise, both way. Progress wise, engineering wise, quality wise, and whatever else is expected of product. That is, we say engineer means person who applies mind as well as physical energy in terms of performance of works. Reliability of engineer is very important in life. If you don't have reliable engineers, we cannot develop in reliable form. We can develop in defective form. We can develop in whatever form, but reliability is a measurement that can entitle everyone to be trustworthy, trustworthy, or you can say in whom everybody has confidence of highest degree. That reliable engineer is required, not engineer alone, engineer with competency and consistency and commitment record. Commitment is also important. Just having competency or consistency do not mean you are reliable. Obligations must be performed, accountability must be affected, and then you can say commitment that person does something. You may be competent, but you do not do anything, you are no meaning at all. That's why I say reliability is applied in works, reliability applies to methods, reliability applies to each and every activity, but ultimately it is individual leader, that is engineer, who has to be reliable. We say works, contracts. It is very general that people know contracts and contractors are involved in life, and particularly in industrial world. Building is also industry, construction is also industry. It may or may not be applicable here, but it is. And that's why title includes it. We include safety also. Safety is paramount important because it means everybody works or working is safe, every personal is safe, every machine is safe, every procedure is safe or takes to or leads to safety, every arrangement is safe, design is safe, design, which is very important, permanent work is safe, methods are based on safety, quality, etc. Otherwise, methods have got no meaning because methods is temporary explanation for permanent work. It can be varied, that's why I am saying temporary, but it can also be called permanent if you reiterate same. And then we say claims for technical work, claims for commercial or any claims that can be for financial matters, claims for quality, and there can be whatever kinds of claims in organizations or in public that our product is claimed to be quality oriented or quality based. We are quality based. Our activities are reliable. Our works are reliable. You trust us, that every organization can expect. And that's why I always take such subjects in hand which says, you can see now my name board. Again I come back to point. This is my email ID, Suraj_engineer, Suraj_engineer at yahoo.co.uk. This is my name board, and this says person is Chartered Engineer India as well as International Professional India, attest to Civil Engineering World. And here is certification, as I included in that, IPEA agreement based International Professional Engineer Certificate. This is Chartered Engineer. That is written here, FIE. You can see here FIE, Fellow of Institution of Engineers, and here file of Coordination Engineering as file of Quality Engineering. These files we often discuss. I will also insert another file that is concrete. So I close this Chartered Engineer certificate. I close Flow certificate, and we now come to Quality World. Quality and coordination I have combined together because files are different but matter is same. So we talk of quality and coordination, which is part of works, which is part of engineering, without which we can say we cannot do anything. This is life, quality and coordination. We have to move together with this. And if we ignore, this means we are not responsible. If we are engineers, we have to be responsible. If we are owners of some company, some industry, some factory, we have to be responsible because we take responsibility of goods we sell. It's not responsibility means social responsibility. Social responsibility is a part of that. But overall responsibility is financial. Product responsibility, we have to deliver product. That product can be whatever form, up to construction works. That product must be produced, must be delivered in a satisfactory form, in a form which has been prescribed or specified, and it is done, and our user, our customer, whoever you can say, uses that item, that good, must be satisfied, must not feel cheated, must not feel that undue advantage has been taken by manufacturer or industrialist or promoter. I am talking of development, and development means production engineering, development means process engineering, development means construction engineering, development is design engineering, and developments. You have to develop your society, your nation, and this applies to everyone. But we have to be all time awakened. We have not to sleep as we usually do. And that's what we have to discuss in very important form. What is solution and what is problem? And problem, we can say problem is absence of quality or missing quality to some extent. We cannot say if quality misses, we can say it is quality product. Why does it miss? That is a question mark. Why does it miss? I always talk about this. It's question everywhere. It must be raised. It should not be ignored. It should not be avoided. To an extent, we avoid it. We avoid our responsibility and we avoid our, we can say, performance efficiency. We run away from job that an engineer should not accept. If an engineer runs away from responsibility, then you can say development runs away from responsibility. Development may be there, but that would be part quality, not full quality. And part quality means part life, not full life. And that should not happen. This may be you may consider it very elementary, but this is a very fact that we sleep from that point of view. Why do we sleep? So if we sleep means our work sleeps, our quality sleeps, and our performance sleeps, our future sleeps. And when we say development is not for 1 minute or 1 second or 1 hour or 1 day. Development means long consideration. Development means works to be done, and that should be used for decades. Work may be done in 6 months or 1 year, but it may be used for 50, 60, 70, 80 years. That's what difference lies in. You can say, I have done this work. Okay, you have done this work. But can you guarantee that it will work for so many years? That's question arises. Means warranted items. Warranty, we should have warranty everywhere. And that warranty, if you don't have, we don't have any responsibility. And that warranty is a part of work. That point we should understand very clearly. And I always say that I write in different forms, as I say here, quality, I say here, quality is that what I'm talking of, and that is, it is my friend. I can consider quality my friend, my relative also. If not friend, because friend is also a relation. So I require quality and I can do whatever is required for that. If hard work is required, fast work is required, additional knowledge is required, or whatever is required, that I have to arrange, and that is job of an engineer, job of him or a responsible person. If you are not an engineer, even if you are an owner of some organization or you are an industrialist, it is your responsibility to do that. Well, I don't think there should be some question on this, because ultimately it's work we are talking of. We are not talking of something else. So I should always say stop sleeping, because I address to quality. I address quality or sleeping, get up. But I have to address myself. I am sleeping. I have to work in qualitative way. And that's very important point. And particularly in our country, I am talking about Bharat, India. Its name is Bharat, India, quality name, according to our law, that is Constitution of India. And this country speaks about how to think of, how to do of, and how to deliver of quality based on coordination. And that is very important part here. And because I talk of quality, I talk of coordination also. And coordination is something we have described many times, and every time we describe in a different way, because there can be no fixed definition of this. Itself is a coordination, means ordinate should cooperate. When you take out one word and ordinate other word, coordination. Ordination means what? Some mandate, and that is co. We have to go in mandate together, or not separately. Means we have to work together. How many maybe we are, with how many documents we have. We have to move together. In fact, there should be no difference or friction among those who work together for same objective. And that is coordination means. You may say also there are so many ways. Nation is not nation geographical, it's nation within you, nation of subject, nation of project. So you have to move together in mind and not physically. Actually, this is movement of mind. Physical movement is not required here, physical working is required. And when you say coordination engineering, this means it's a combined engineering by all people together, not subject engineering or not discipline engineering, because discipline is smaller if compared to word of coordination. You cannot isolate it in some discipline form, because it applies everywhere in all sources of life, if not only in engineering, in all lives activities. Coordination is very important, and people, whether do successfully or do not do successfully, it depends on culture of work, responsibility, liability. And if we do not do this, we can say we can do a mistake. We can call ourselves, means what should I say if I don't understand this coordination value. Coordination and engineers have integrated relation, because without coordination affected by mind, engineering cannot move, as well as without coordination affected by works, engineering cannot move. And when engineering cannot move, you say what happens? Nothing can move, we cannot achieve any quality in works or any good works, because coordination has failed. And that's why I am trying to open eyes and minds of everyone, that you have to keep yourselves up. Don't think quality means expenses or cost. That is delusionary answer. That is delusionary, or you can say delusionary thinking. There is no illustration at all that if you do quality work, you spend more money. That is misconception. That is misleading conversation. Quality, coordination are related. Quality and products are related. And you can say quality and designs are related. Quality and personnel are related. And you can say whatever you consider, quality comes into action. And also you can say communication and coordination work together. And coordination along with communication can help everyone, can support everyone. And that's a point, you can say, part and parcel of coordination, reliable coordination. That point we have to understand. I always talk of some projects. I think it's better to refer to projects, because projects give you something that no one can give you, and that is referral, that is reference. And this for example, this photo, this view says that it's always plants. Life is a plant, you can say. It's always plant, which is a manufacturing unit, a processing unit, chemical processing unit, or petrochemical product units, or powerhouse, or whatever supports your life in industrial form. And that's very important for life, and it is done based on technology. We have technologies, we require to convert that technology to production through these installations of plants, generation of engineering. And these plants perform based on technology and based of infrastructure provided, or even say chemical construction engineering is provided. And it involves all engineering disciplines or engineering branches while we do designs and construction. Or we can say we procure some engineering, we procure some designs, and we work out, and then we implement that. We call it facilities, plants, or whatever. Our life should be that. We should not be isolated. We have to integrate our efforts. And it's firing range or shooting range. You have to shoot, though it's not that shooting, it's real shooting. Is a training for soldiers to teach them about shooting, and that is life itself. You have to shoot your, arrows out. And it's a plant of same processing, plant of same area, and we can say some description here. And then it's also a part of that plant, cooling water plant or seawater basin, which delivers water for cooling to whole area. Where equipment are required, those equipments are heated during processing. That heat must be cooled down, and we can say is after use water is circulated for purpose of reuse, and that's the water basin. And then we have some other building for digital recording of some petrochemical product. And we have here some other plate that can be said to be a hospital building, an important work which should be checked thoroughly. So I don't have records of this. Also, this is LNG plant, and we have to say something on this. If we can, we will see this. I'm just moving on fast. This is also plants administration area, and you may go further and see some slides like that. This is also chemical processing manufacturing, cracked, you can say cracking furnaces, and also this is, you can say, this is another same one but different view, also processing area part. And here is what are structures. This is a small house, not very big house, of course. In terms of engineering, though, it's good one for people who know how to construct. This is a building, real building. It is a time when construction was done, and you can see that this is a framed structure where you can see beams and columns as well as slabs. Vertical members are called columns. People usually call them pillars. I don't mind that because they don't know what's difference. So if you can say pillar, it's up to you. For me, pillar is column, and also the horizontal members are generally called beams. Beams and horizontal continuous areas, you can say, is called slab. So also three elements, columns, beams and slabs, are generally known to people. That's the important part which which every common citizen should know, but it's not known to them. They know only what they see or what our artisans like masons, they tell them. And therefore I say this is called plotted house, not apartments. Even if it is an apartment, doesn't matter for me. It doesn't matter to me because it's work. It is very small house, you can say, only 400, you can say about 25 or 20 square meter plot area, and some numbers say 55 to 60%. And that's purpose is not what I'm showing. Purpose is sequence and quality, what we say. And this is important nowadays because structures are important for works, for projects. For first of all, we have to achieve quality, and then we have to comply by major requirements of wind forces or earthquake forces on buildings. And that's a very important point we have to understand in our life. And if we don't do that, we will never understand what is quality. We'll see buildings, but not to that level, not to that standard they should be. That's why we have to understand this point. And here are salient feature of this house. I've said here that it's salient features of construction, and it is, we say front portion double height, okay, that's okay, fine. Rear portion is bedroom area in 3 stories, that's also fine. And ground floor portion is whatever is previously constructed was 75 square meter, and then currently constructed was silk. Important is other properties, soil, Silty clay with high affinity to water and white ends. And depth of formation level is minus 3.4 because of basement. When we go minus means below 0, if we go it's minus, and above 0, 0 means any level, whatever level fixed on site. For purpose of reference, we can call this 0 level, or sometimes we call 100 plus, it depends, means a reference it is to go down or go down. That reference is levels. In engineering we consider levels because vertical movement is controlled in levels, while horizontal movement is flat level, 0 level, and we can say x and y values etc. we take there, or we can say this end is positive, this is negative. Same way here, vertically it's positive and below we go it's negative. Or we can say excavation carried out by machines, of course, and some partial excavation was conducted where machine could not go due to constraints in area, confinement in area, and we use some other workers. These are also called donkey workers, donkey laborers. Donkey is an animal in a society where loads can be transported using it, and that's a very ancient practice. We have to see how we did this. Important point here, including really also, is that people should know what's value of construction, what's value of building. You simply cannot say it's only 1 story, 2 story, 3 story. Question is not story, question is importance of life. So we can say in this project, important point is that we should be clear about this. Whatever work we do in life, work is work. We cannot just skip off that. You cannot say, I consider even small work is work. And we have to think seriously about that. Because we cannot just joke with anything. It's cost, it's time, and it is spent means gone. You cannot take it back. This is a problem. If I do some work, let us say concrete, or concrete once you have done it means done it. You cannot you cannot change it, or you cannot say come back, I'll check you and give you back again. You send you back again. That's not possible. And moreover, once it is done, it shall stay there until it is demolished. So stay there until it, or for a duration it likes. And even after that, if you do proper retrofitting, you may continue and continue. So question is, what we should do, what we should think about soil engineering, which it's an important part of engineering. Soil engineering, soil is very much important item. It's material, in fact, natural material we consider, because soil gives everything to us, whole world. So we have to be a very important person in this case, and yet soil must be cared about. But it is unfortunate that the most important material is soil, not only in buildings, in all structures, because soil ultimately transmits all forces coming onto structure to ground below. And that soil should be known, but people think in a very different way. They have their own world of construction, not a real world of construction. And those who know importance of construction, they do not let it go as it, but they want to know what we should be done, what we should do, what we have to do. And that's we can say soil is taken care of, because soil is also not clearly known till now in absolute terms. It's not very old subjects, you can say 500 years, it's not very old subjects, but it's very important subjects. Soil, classification of soil has been done, and actually I'm not concerned about classification of soil. I want to understand soil, understanding soil, understanding nature of ground, understanding your material, and understanding how you do expect performance of this structure, this building. You see, book-wise or theory-wise, we can say anything. But once we have to think ourselves, so that's the important point, because engineer means a person who can think in a creative way. If I cannot think in a creative way, I cannot call that I'm an engineer. That's the important point. Though I'm not an engineer of repute, I'm not engineer leader, but you see, it's not purpose of engineers that you should be known to everybody. The purpose is that you have to deliver works, whatever works required by whosoever. And that's very important point, that we have to understand all this. When you are an engineer, you have active brain. Some have active brain, some have still passive brain, and some have very dashing or dominating brain. Well, there are so many types of classifications. The point is same. As a student or a learner, what should be your body strength? What's your mind strength? When you are in classes, you are in university, or you are in colleges, you have duty to learn and to get in yourself forever. Study, education is an important part of life, and it makes us, it changes us. We have so many files in our domain of law, but how many are actually used? That's a point of concern. People say we do something, they also do not understand what they should do. Same way is quality talk, quality construction, quality designs, and we must have some patience while we work in designs or work in engineering. And working engineering is more important than just be blank designer, because engineering means you have to run. You have to run country, you have to run masses, you have to learn about all goods or bads. You see, bads can be earned very fast. Good takes time. So if you combine two, we may get something about something. That's the only point. We have to know facts also. That's another point. So when I say when I thought to construct this building, then I checked soil of that area, and I was disappointed seeing that soil, because of nature of soil, like what I say always, clay soil is very important one for something, but not important for other thing. So I said that I started thinking on this, and you can say soil improvement we had to do by replacement of bad soil with replacement of good graded material. Why this happened? Because of observations I experienced on this. I did not go into theoretical details, but I wanted to see natural conduct, natural response this soil gives. So I just excavated to some extent some small foundation like though in different area, and its reporting told us that this is not suitable for every construction. This may be suitable for your current time, current works or current jobs, but in fact you won't be happy with this because you have a desire to get more and more. Well, it's different way. Now what I observed that on this soil, I had one pit about same 1 meter, 1.2 something or 2 meter deep pit. I observed that for 6 months myself. Means not sitting there, but experience by visits, and made sure that what sort of soil is this. And I reached that it has adequate quantity of clay. It could be called clay soil, or silt contents too. You may say silty clay soil. You can say that, it's not a problem. I can say it did not fall, sides did not subside, side didn't go down, and it remained stable, not having any strength. You can say there was no problem in excavation, and we had to observe this. Soil was self-supporting, and all conditions are says. You could say it mandated or it confirmed that it was good soil, or you can say it's a soil which can be used for purpose of founding our buildings. But still, I was not happy with that because I did not want to create any contract between artificial material, artificial stone, that's concrete, and you can say remaining bars, whatever we have. To treat those bars, we had to take to some, you can say, take to some place where it can be done, or like some mechanism sold, there's standard practice, you can say all this. So you can say also I had observed this pit, and this pit confirmed that this soil was very bad. In fact, it's very, very bad, but we had to go down to 3 meters more. So there will be some betterment, but I didn't do anything. We have to improve the soil. At least I thought that we could take up to 10 tons of bearing capacity per square meter, working bearing capacity you can say, and that's, if that soil means, there are chances due to its nature or due to water porosity or moisture penetration into soil, this may cause some errors, which errors should be clearly, you can say clearly taken out from that complication, or we cannot make full use of soil. And there's a misconception among people that clay, or they don't know clay it is, they say it settles itself or it makes itself, which also not engineering concept. It's only misleading talk sometimes, you can say. I don't want that. The purpose is using it for certain foundation or certain other requirements. Therefore, soil is considered very important material in engineering or otherwise also, because we use for walking, we use for travel, we use for sales, we use for every part of life, whatever we say. Construction, world construction engineering, and this cannot be condemned at all. And if we condemn it, means we condemn ourselves, because it's, you can say, development, original work. It's development, original material, which point cannot be just ignored. And that's why I try to concentrate on this all time. I can say, when we don't find good soil, if it is clay or silt, which is all dangerous due to their own properties, that must be taken care of. What properties could be that we have to think of and take. And generally we say, depending on nature, I could reach to certain conclusion, and we decided that we will take this much. And that is practical way, means you have to decide something. Even in case you don't have laboratory, you don't have safe bearing, you can see yourself by walking on that. Means clay is a compressible soil, we know. Compressible soil, and also dangerous in sense of contents of water. It swells to many hundred times. You can say many hundred percentages it swells. Well, water is penetrated into this and becomes a porous water, and that is difficult to extract out. But when it is compressible one, it increases in volume, or it decreases so much that you cannot use it immediately for your works. So we have to see that what bearing capacity I could expect of that. I assume it could be 5 to 10 tons, or maybe less. Maybe less. The reason being that I say, what I write here, I just see SPC of soil to be somewhere 5 to 10 tons based on my experience. It could have mineral like montmorillonite or illonite. And that's a very important point here. Illonite, mineralite, that we have to check seriously. It's not simply a joke, but it's a fact, And you may say, we have to understand this point in each and every aspect of project value. And file is playing something. How it's playing. Coordination engineering. I open what's file and see if there's some difference of finding some difference here. And I assume a corrected file. What's that corrected file is? This correct file is something, maybe some problem in saving of that yesterday. Let me see what can I get again. This change. What is saying something else? It's not saying something else. Just a minute, please. Let me check it. What I did yesterday is not been seen in this PDF file, so I have to be very specific about that. Yes, there is something. I think I did not save it properly. Let me save it again, and that means I have to close this file, otherwise it will not open. Just a minute, please. Let me see it. How does that work? Let me close it first. We'll save, not save, otherwise. Just a minute. Just a minute. Let me do it again for you people. It's this file actually. I say print it out. Let me see how does it work. Hold on, please a minute. Hold on, please a second. Just a minute, it's processing. It's a big file, 53 pages now, so it takes some time. And it's really wonderful if it does well. It's coming up, I think. It's coming up, processing, and it's going up. At any moment, it can be here. It's here now. It changes, I think. It changes, and it's called PDF. Now it's come. I think it's come. Coordination engineering has come. Again, let me say if it gives same, which I expected. I think it's same now. It's giving same. So I should be clearly, I should show first. It's saying. Okay, let me save it. We can save, otherwise it's a problem. Save as. So it is saving. Now I'll be back on this same chapter. I'll close this file first of all. The purposes of what I close this file, and yes, it's I just took it's same. It's same. We can say it's same. Let me see how does it come out. Might be there was some error in the previous one. But I forgot to say could be possibly. Alright, so I come back here and it says now, you know why I doubted, because there are some changes in sequence, and no problem. That's, you may also do that, you can think that way, but sometimes it's also, sometimes it happens that what actually I made, I know. So what I say about this soil improvement here, it's a very important part here. 180, you can say. So okay, now I say again a soil improvement by filling 40 mm graded aggregate 250 mm thick, followed by placing 10 mm graded aggregate, and then on that place graded machine dust like this. It is that. So in this case, as I discussed with you, I experienced on this and this pit, excavated pit, for a couple of months. I had time. It's a kind of research that I wanted to see. I wanted to make sure conduct of this soil, how shall it behave and how does it behave. And that I said, if you see at point number one, soil improvement by filling 40 mm graded aggregate 250 mm thick, followed by placing 10 mm graded aggregate, and then on that placed graded machine dust. This is point number one, which gives solution to what I expected, a problem, an issue. And this is actually, you can say, first stage of soil improvement. I just put in, and then in second point it says above mix compacted, dry as well as wet, to achieve adequate density for mix so as to enhance bearing capacity as well as to reduce settlement. Now this is solution. Our solution is I had to remove this bad soil or clay soil, maybe clay with organic substances, organic parts, organic materials because of agricultural nature, and it had, so I removed extra below formation level about one, I can say 300 mm I removed for this purpose, and it was replaced with first lay down 40 mm aggregate, that is called wapsi in our language. In Delhi we call it wapsi, though it is stone aggregate. You should not confuse 40 mm size, nominal size, and also you can say it was about 250 mm thick, which was followed by placing 10 mm graded aggregate to fill in voids of wapsi or 40 mm aggregate. Means when I say 10 mm doesn't exactly mean 10 mm, it can be up to 12.5 mm something. So 40 mm and then voids filled with other smaller size, and of course then whatever voids were balanced in that volume of aggregate, coarse sand or not coarse sand, if you have stone dust, in fact we have procured stone dust. It's better to use stone dust in place of sand, so that whatever volumes were remaining filled with this dust. So you can say kind of bigger size, then lesser bigger, or you can smaller size and then smallest size. This was filled in to convert it to a solid material. And what we did, we compacted it dry as well as wet. Above mix compacted dry as well as wet to achieve adequate density. What is required? Adequate density is like near concrete, we may say. We compact it. The question is dry compaction and wet compaction, just like we used to do in doors, roads structure, roads carriageway structure. We do that, and water is used as binding material for that. And once these are interlocked together by, we say 40 mm, 25 mm dust size, these are interlocked, these are locked for permanent times to come. You can say as aforesaid mix compacted dry as well as wet to achieve adequate density or required density for mix, which can so as to enhance bearing capacity and to reduce settlement. Many times bearing capacity is improved like this. And as I said, I observed pit, as you can say 1 meter by 1 meter by 2 meter deep for about 6 months. It was not question of time, question of understanding soil. It's important here, because soil is always misunderstood by engineers. I don't say they don't know it, but subjects are not clear, and that's my point. Subjects are not clear, writings are there, professors and they write that. In the field what we get, that's important. How much we can understand, how can we apply that, or it's just imagination. So that's the point here. So I can say I have to trust that one. This point number 3. And for point number 4, there was no problem in excavation, it seemed, because soil was soft, or it could be just converted to that level, go down. There seemed no problem in excavation, and no requirement of any shoring during excavation, because soil was of self-supporting nature, and only on one side, one building existed, other side 3-story building existed, but on the other side, which is a driveway side, it's about 3 or more than 3 meters available, which you could not be excavated. So there was lesser chances of subsidence of existing buildings. Okay, then what happened then after that? So I can say there was no problem, there was no issue in excavation, and of course there was no requirement of any shoring support during excavation, which indicates that soil was self-supporting, and clay is generally that. If it's good clay, you'll be having no angle of friction, but due to possessing high value of cohesion, That's why we say we have to protect soil as well until foundations are constructed and we come up to that level. Substrata did not have any water table, that's true. If they have in the water table, this means this was very difficult situation to handle. This was a positive point, there was no water table. Substrata did not have any water table, but certain moisture, very nominal. In that case, you can understand what I'm talking of. And it appears that land was used for purpose of cultivation or agriculture industry. If you go to long past of forestry, it was agricultural land, and every country has that system. You have to convert agricultural land to your housing areas, housing requirements, which is general practice, and we should accept that as well. You can say it appears that land was used for purpose of agriculture in long past, and for development of area, development authority acquired this land for urbanization around Delhi. So that is different aspect. Now, soil definitely at point number 7. Point in this list, maybe in this number change later, I can't say, but in this video it's okay. Soil definitely contained certain organic chemicals that have had to be avoided to be there permanently to impart adverse effect to building or building structure. Definitely soil contains certain organic chemicals or organic matters that had to be avoided to impart adverse effect to building. So that's what I say. I had my own observation, and based on that observation, it was just that SBC, or which is called safe bearing capacity of soil, whatever soil it is, safe bearing capacity is required to be known for application of engineering. So SBC, that's safe bearing capacity of soil, I adjust to be around 5 tons to 10 tons per square meter, which is good one. Means if you want to construct some small building of small height, I don't think it's not a big issue. It's not the biggest at all if you have understanding of soil, it's clay or it's sand or it's rock or what it is. Though 5 to 10 tons per square meter, it's not a big issue. And then we can say it's based on my experience. Yet they did not meet building requirement. Building requirements are different, but we have to see with that. And due to unforeseen behavior of conduct of behavior clays, due to unexpected, unforeseen behavior of clay, that could have minerals. It could have minerals, of course. Clay cannot be just called clay. There is a reason why this name is because clay has got certain minerals within this. Clay soil has minerals because of its nature, and it's expandable and mineral like you can say. Montmorillonite is one mineral. It's written here in point by 8. You can see Montmorillonite is, you can say, in middle somewhere where you can see that unforeseen behavior of clays that could have minerals like Montmorillonite or illonite or some others that could help soil to swell when it comes in contact with water, or while being in contact with water, or loosen entire shear strength, and that is very dangerous point of view because of availability of Montmorillonite, or you can say illonite, or also the other names are there called illonite like this. So we just keep it to Montmorillonite, which is very, very dangerous mineral because of its nature of expansion or shrinking. Generally we call that when clay soil comes in contact with water, it swells to many, many hundred times or percentage wise, and you can see that it becomes very soft, and it seems that there is nothing in that at that moment. But when reverse happens, when water is evaporated, in that case you can say despite having some portion of water left, it acts as strong, there's a fracture in surface, you can see some cracks appearance there in surface. So you cannot predict right way about soil, clay. That's why you have to think in different terms. It's very important to know because it's not clear yet. I'm saying montmorillonite is very big chemical here. It's available in mineral form. It's very dangerous for this and that. So it's a question of concern how to stay away from that endangering chemical, montmorillonite. Means I don't want any swelling or I don't want any squeezing on this soil, yet you can't help otherwise. You can have protective measures, in that case they will happen. And then we can go to point number 9. Proposal was to include one equal, they call it size basement. That could be my concern. Proposal was to include one equal size basement, and that could be my concern. I decided to avoid formation of foundations on existing soil, even at cost of additional, expenses. Means I wanted to, you can say, I had decided to avoid formation of foundations, no independent footings on existing soil because of various reasons. No trust with that soil properties. Whatever trust we have, that is not dependent on our survival, but depends on what force we have. So we can say, after that montmorillonite issue, we propose to include one equal size basement. That caused me a concern. Then what I did, I had decided to avoid formation of foundations on existing soil, even at cost of additional expenses. But as I explained in foregoing, that we had to improve soil, it was not a game alone, it was a requirement. Therefore, I am very serious about this issue, that we have to be clear what is difference between clay and sand or clay and silt. It's very clear difference. Clay is very dangerous. Sand, if much, is little dangerous, you can say, and if it's nothing, it's fully dangerous. We cannot think how to allow this, or we can't think about how to control it. We have to be very realistic about that. What I'm talking of, in fact. So we can say also, I had experienced during my career extensively on RCC building projects, of course, as well as industrial onshore projects, both in office engineering as well as field engineering. Office engineering is not very common word in engineering, but it's a fact that office engineering has longer life than living engineering. That we will discuss sometime else, but I'm just telling what's office engineering. That's the point, that office engineering is very significant, or you can call it coordination engineering, or you can call it technical engineering, or methodist writing, or whatever you can call it, where work is documented and supported to those who do not do that. And this documentation is considered very important, because we cannot always use every part for cleaning every time. It's no good. Therefore, what we can say is, my experience was during my career till that time when I did this, it was extensively on RCC structures, those RCC structures, and also having daily that's very important point. I said I have experienced equal size basement. That caused me a concern. I had decided to avoid formation of foundations on existing soil, even at cost of additional expenses. Let me switch off this battery. It's free charge. Then I sit down back because battery is an important issue in laptop. Sorry. My leg is also. Okay, let us continue. So, my dear fellows, it is different kind of talk, as I usually say. Don't mix up with this. This is practical taste engineering. This is actually field engineering with field understanding, field concept, not design concept, field concepts, practical life concepts, and it cannot be, you can say, thought of, but you have to experience that one. There's so many points I could learn in my life about this. It's now 13 degrees Celsius with dew point 11 degrees, 13 degrees cloud, and visibility is 8 kilometers. Cloud ceiling is 12.2 kilometer. Day is expected 27 with small rain, it shows 0.4 mm, and next night temperature is 13 degrees. So it is little colder now. In beginning it was 14, I think 15 degrees. So it has come down. That's 14 kilometers sterling winds. Humidity is 87% and it's considerable. So why I'm saying this? I'm saying this just for fun, you can say. It's not for fun, but telling you we should keep an eye on everything, and that's why I'm feeling cold now. No issue. Let us go. As fast as we started, it was about 3:45 or something. Now it is about 1 hour gone, and we have to move further. And as I said, I believe in new knowledge. We have to get more information as much as we can have from field engineering, that is site engineering and engineering itself. Engineering concept, when we say engineering, coordination engineering, it's a different word, means engineering on site. Maybe it's not understood here, but it's a discipline, in fact working discipline, not named discipline, coordination engineering, because this is not a specific one, this is general one. Coordination applies to all disciplines, all branches of engineering, and we have to respect that way. We have to understand coordination if we want to really correlate it to quality system or to product standard. And we can start, as I said here, I tried to understand soil first, because even if you give it to laboratory, you will get so many pages reports, which is good one for complete understanding of soil. But here we thought that let us know in a different mode. I also experimented there, how it is really wonderful that I take, let's say, the tumbler, you can say glass container, in which you put some water and also soil together, small soil, let's say 1 or 2 spoon, and stir well. Stir well means all particles try to be separated and well merged, and then let's allow it to settle for a couple of hours. We see that we say all particles mix up again, try to coagulate and then settle down. And then we can say percentage wise the turbidity of different sections indicate what level of soil it is. It's opaque or it's transparent or it's clay one, or you can say it is like that. We have to this, you can say. So we decided that we have to improve soil. As I said in my foregoing statement, we have to improve soil. So we selected to improve it, come what may, we will not leave it. because our zone is zone 4 according to earthquake arrangement, earthquake prescriptions in our codes. Zone 4 is dangerous zone. We do not want to take any responsibility of future accidents or future failures of this structure. So when I say soil improvement was a decision, decision was made to apply soil improvement technology or technique in easiest way so that bearing capacity as well as permeability of soil below formation is sustainable. Means that reception of clay is not allowed in that case. So water should not affect foundations also, that we have to see. If water is allowed to move beneath foundation structures, that point also very important. Sometimes we can do it by many means, but sometimes it's not by many means. It's only means, you can say. That's why we have to move forward in this way. And what I said then, that soil, you can say, I think it's not moving. Why? Let us see this. Let's move on this. Okay. So you can say, based on my experience I have gone through, then this decision was made, that's okay. Water should not affect foundation, that's also a requirement. It should affect, but not to that extent, should not feel like flood it. If water is allowed to move beneath the foundation structure, water should not affect foundations. If water is allowed to move beneath foundation structure, if we provide water there below structure, it shall impact, but it should be given protection against that. Water should not affect foundations, and clay soil had to be isolated. Clay soil which existed had to be isolated from building substructure for purpose of RCC perfection. We say perfection, but there is no such perfection at all. Water, you can say, water should not affect foundations if water is allowed to move beneath foundation structure, and clay soil had to be isolated from building also, building substructure for purpose of RCC protection. Means when we say we have to protect RCC, we use other methods, but here we have to protect it from, use different material, and that is filling, you can say, dunes is C or B sand around article members and other samples such as penetration, that is red puggery, and that red puggery likewise, you can say, very important. We cannot just enjoy anything. And also some person in that case, because there are no, suggested me to mix up lime in foundation. Well, I did not take his logical idea. It was something randomly wrong answer by someone. So we can say, okay, our requirement is that we will make water bound like structure below foundations by improving soil. And that's, I think, practical answer. There are many solutions as well. Depends upon what problem we have. And I can say then some person says, okay, I went ahead to excavate about 300 mm soil additional depth to accommodate proposed soil improvement technology to minimal meeting. It should be more that I did not attend to take risk more than that. Who would like to have risks? Nobody. But why to have risk when there's technology? Due to excessive depth, I said it could be more, but I did not intend to take more risk, because due to excessive depth of excavation, when two sides existing building up to 3 stories are located. Formation was prepared and 40 aggregate, which is called Wapsi in Delhi terminology, is added to. Now we go to the next point here. Later, said 10 aggregate was placed on 40 layer, and so the voids within 40 aggregate is filled with 10 aggregate and then by dust. Additional layer of machine dust, graded dust was placed or spread so that you can say voids within 10 aggregates be filled with mechanically provided dust. All was watered, whatever we did was watered and compacted by external vibrator, or you can say jackhammer type, and you can say all was watered and compacted as it is done on a water-bound macadam road structure formation. Also notice after doing compaction that the formation was very strong, and there was really not much improvement on as you see. That's our requirement here. If we say all was water then compacted just is done in water-bound macadam road structure. And I noticed after doing compaction that formation was quite good and it was worth. Now this foregoing fill has to respond to all was water and compact just is done on water-bound macadam road structure formation. I noticed after doing compaction the formation was so very strong and there was really much improvement on SPC. This foregoing fill has to respond to work as permeable medium also. It's permeable, which can allow transport of water from one place to other place. You can say foregoing fill has to respond to work as a permeable medium clay also, and for downwards flowing water as well as to allow a break for upward flowing which could be a result of heavy rains or due to whatever reason it be. This provision has also affected as a barricade for clay soil so as not to remain in contact with foundations. This is a kind of different technology. By experiment we do something, it's good one, because we provided one filter on clay formation. This filter is, as I said, it will filter out impurities, organic, otherwise. So this is, you can say, this provision has also affected barricade for clay. It's a barricade now, means after application of that method. Now we go further that water in future that could be a result of heavy rains or due to whatever reason. This provision has also affected as barricade for clay soil so as not to remain in contact with foundations. Now if you see point number 22 come on. In addition to above, on sides of fixed retaining RCC walls built between main columns, fill material used is river sand. This is in RCC foundations where fill is required, said, and where water tank is to be constructed, that is not to be filled and except to fill with water at later stage. In addition to above sides, okay, this is okay, fine. Now, river sand was used so that it allowed water to have permeability as well as you can say, since clay does not possess a property but allows considerable porosity. Porosity is important in case of clay, means it's compressible one. Virtually, you may say, virtually foundations built are soil contact free, and portions between RCC beams, foundations joining all columns in both directions. Exclusively river sand was used as a filling material. Filling material, we call it engineering material. Virtually foundation built are soil contact free and portions below all RCC beams in foundations joining all columns in both directions. Exclusively river sand was used as backfill material to avoid cumbersome work of backfill and compaction of compaction of soils, either to be taken from site or selected earth or to be imported one from a reliable source or to design and to define. So we have to go forward and see what's written here. I said here, backfill compaction of soils, either to be taken from site as selected earth or to be imported from a reliable source or to design, etc. Let's say design real, you can say earth, or to be imported from reliable source, or to design real density fill per FTD, that is field right density requirement, could be procured from certain type of granular materials. Well, I think what was done economically in all respects, economically inducing to foundation, was necessitated from practical engineering construction viewpoint. We can then say, now we talk something about structural on prepared soil, how you say is prepared soil or improved soil formation layer it is. And it's also very important here. On this prepared soil improvement course, compacted rough course, a 50 mm thick blinding concrete pass the heat, and that's very common. Surface of blinding concrete waterproofed using one tape grid material, polymerized cement it is. You see I have to use cement in mortar. So we solidified by So we'll now move on to this topic again here. As I said, is that we applied waterproofing on that. That is you can say polymerized cement application, which forms on site on its applied a impervious layer. Water cannot cross that barrier. This is indicated on its use, its objective. It says that analysis of foundation frame was done by using Carney's contribution method. It is also very important part. It's not used, but I customized this application 3-cycle based rotation method myself and used for all frames, whatever we had built in a direction or in planned forces. So remains vertical members which are then exfil is done. Now we move into other one that now sketches, as I showed to you before also. We use this method of Carney's for that solution in terms of theory of structure and designs. Carney's contribution is very interesting, in fact. It's easier, it's very fast if properly developed. And I developed in terms of 2-way, 1-story, 2-story, 2 up to 3-way, 4-way and 5-way likewise. And this you can see foundation is shown in this sketch as given herein. Thereafter I'll show you that one. And you can say drawing sketch shows very interesting one. What is in you can say in both directions this frame was done. I'll show you that one as well. What is that? I'll show you that one. Embedded still you can say I'll show you sketch in the sense of that. There is also established one water tank in between foundations, surrounding foundations. That's what is different kind of approach, in conventional, non-conventional, and also reverse and fill as I said before. And externally 450 wide and portion filled with reverse sand. Externally also you can say on other side of retaining wall we have to fill with equivalent size of radium calcium. And then we go to see there is a sketch here. You can see that sketch. You can see clearly if I blow it up, you can see in broad form. You may start this foundation. This is first of all, this is here foundation beam. As I said, soil improvement is first, and this is you can say kind of spreader, and this is beam. A kind of this geometry which is good for, if geometry means this is not footing, otherwise this foundation you can say is a kind of connections to all columns and continuity of that beam which acts as foundation, no additional foundations. It also acts as dwarf wall and is like a purpose made structural takht. May call it structural power resistant materials and foundations. And what beauty is here that these foundations, here you can say connections to all columns and beams. You can see dark line here, and that's important point, and you can see also here same kind of technology is used here. Now what's specific in this is what said that retaining walls 200 mm thick, providing right around foundations to hold fill, you can say hold fill, backfill. Wall reinforced with 8 mm dia 8 mm dia steel bars, those taut one high yield, and you can say also 200 centers both ways. Main hall portion along 12 columns 100 by 400 mm from bottom to top, while 600 by 400 mm 8 columns also in parts of hall but independent working. Main hull portion allowed 12 columns 1 by 400 mm 4 columns, while 600 by 400 mm 8 number columns. So you can say span between column 11 meter in 2 frames, while 8 meter in 3 frames. Frame I am saying grid wise, or grid 1, grid 2 likewise. That's called frame. It's actually part of frame, or you can say layered part of frame, multi-story part of frame. Because certain frames are located in double height area of hall, and certain are in other areas. We have front balcony at floor level, structural floor level. It's an important point. Front allows 180 centimeter, 1.8 mm balcony, while sides balcony is only 1000 mm, 1 meter. Also, you can say 6 beams provided in front balconies at both levels, that is cantilever beams, 6 beams, and main beams permitted 300 into 600 meter section for stability solution. So our balcony is based on extended force, whatever reason. We can now say that certain frames are located double height. Front allows 100 meter wide balcony, and likewise we said main, because 6 beams provided in front balconies at both levels. Main beams provided 300 and 600 mm section for stability resolution. Cross beams included 20 by 30 or 200 by 300 mm section. Stairways provided I'm just giving you some glimpses of what we did. Main portions. Stairways slab provided 200 mm thick with rebars which matched in top and bottom layers. All suspended slabs included with 8 meters risers and 200 mm center, both types of bottoms. We have rear beam bed also here. We have rear bedrooms already in one story available. That portion constructed with 11 columns. Well, you see plan, you can understand, just I'm briefing it for information. What is important, and these are ordinary columns, you can say. We can see the quantity, that's about 250 plus 250 cubic meter plus RCC, more than 250 meters, constructed using M30 25 grade concrete. Form support system employed using rented profs only, no structural scaffold or supporting system. Means is ordinary as well as normal system I tried must have at least required safety, if not full. Form material employed in general for 12 plywood, in general 12 plywood for you can say for general, and also it is battens we used, that is 50 by 75 hardwood and 50 by 100 softwood as well, which was used for purpose. Hardwood was used for support of slabs, supporting plates, you can say, for columns, etc. Other one, soft wood, that is 50 by 100 50 by 75 sorry. Total quantity of rebars we use about 22 tons in this case, 22 tons, and we can say total quantity is 22 tons of steel up to ground level 8,000 kilogram and above ground 14,000 kilogram. 14 tons above ground and 8 tons below ground. Labor workforce element, we can say. Contractor did not include curing element, which I did myself, which I had to do this part. I of course did not find any problem for suspended slabs curing, but for columns and brick walls there was some hard work. Though proposed use of building is for resident purpose, for local authority, yet visitors consider building to be not looking as residential one, but either commercial or certain other office, you can say. Now, coming to specific general discussion, so it's very particular for this building. Now, we're going to do as much possible. As we said already, deliberations I'm always interested in, because engineering means deliberations. We have to realize this point very much in our life. After all, what is deliberation? Why we use this word deliberation or deliberation, you can say. We have to come out of secrets. We have to come out of secrets which could not understand, but at one time life itself teaches us what you don't understand. As we say, coordination is always a very important work. Coordination, which is actually missing everywhere. It's not understood. Why I don't know. I can't answer this. As we usually confer on this, we try to explain, we try to understand, we try to let youth understand it. Coordination, as I said before also, all people should stay one place or in virtual mode, one place, and find solution to every part of audience in terms of it's very important, in fact, coordination, and we cannot move without its coordination can therefore be defined in a way that all branches of engineering and all disciplines involved in ongoing activity must be clearly described and detailed in so that no information is left out that could hold progress on activity or part of whatever activity. And there are various ways to resolutions. If what to say, if one small, it's very often said, if even one small information made or we can say, even if one small information is held without having adequate details or is not formally confirmed, activity can stop, activity's progress can stop, and it shall be carried out based on either correct or incorrect knowledge possessed by site team, which work could be considered to next confirmation can also be constructed. Alright. So we have to be very careful about missing information. Missing informations we can't continue. Now we can continue without information means we can make mistakes. And that's what I said always. Even if one small information is missing, we cannot do work on that activity. We stop there if we are real engineers. We should not think of those people online directly that they can avoid it. And I never fought in that. Yes. We are saying now absence of inclusion of this very significant subject within engineering program explicitly met the indication actually uh, so we can say absence of inclusion of this very significant subject within engineering program explicitly indicates that or evidences that either professionals do not understand engineering theories or they don't